We are looking at linear inequalities in problem solving. So linear inequality in one variable is an inequality that can be written in the form ax plus b is less than c, where a, b, and c are real numbers, and a can't be 0 because then it would just be b is less than c. There are different ways that we can get our answer. We're going to talk about those as we go through it. The main thing you need to understand is that the infinities always have parentheses next to them. They never got a bracket. If there's a line, like a greater than or equal to or less than or equal to, then your number will have a bracket. If there's not a line and it's just a greater than or a less than, it will get parentheses. Negative infinity is always going to be on your left. Positive infinity is always on the right in the interval notation. And when you multiply or divide across an inequality by a negative number, you want to flip that inequality. So interval notation, you want to graph it first. You only need the numbers that are necessary in the problem. You don't have to put a whole bunch. I'm going to show you what that means. And then we'll copy the notation below to the graph. And then when we graph less than, the arrow goes left, greater than, the arrow goes right. That's according to the x. And then we'll come back to our example, which is a word problem. All right, so let's look at our first example. So for example 1, we are going to graph on a number line. And then we're going to write our answer in interval notation. So our first example, I'm going to use that set notation, x such that x is greater than or equal to 2. What I want you to understand is that just as x, that line is such that x is greater than or equal to 2. This means the same thing as x is greater than or equal to 2. So really you just need to pull out the x is greater than or equal to 2. All right, so if we're looking at x is greater than or equal to 2, let's draw our number line. And we'll put our infinities on there, and then we're going to put the 2. We don't need to put any other numbers than that. And this makes it easier when you're trying to do fractions. You're not trying to figure out where they land. So x is the x part. X is on the big open part, so that means on the greater side. X is greater than or equal to 2. So greater than goes to the right. They kind of match, greater than and right. Because of the line down here that tells me it's also equal to it, it includes it, so that's why it gets the bracket. Line here means lines right there. Now you can bring it straight down for your interval notation. You get bracket to infinity parenthesis. Infinities always get a parenthesis. All right, let's do another example. We have x is less than negative 1. Draw our number line. Negative 1, negative infinity, and infinity. X is on the small pointy side, so it's less than. When it's less than, it goes to the left. Because it doesn't have the equal to, it will get a parenthesis. So it'll be negative infinity to negative 1 with a parenthesis. Now, it's not because the point is facing that way or the point is facing that way. I could write this as this. This means the same thing as that. Now it's pointing that way, but it's still going to go that way. The same thing could happen on this one. X is still less than negative 1 here because we look at the x. It's at the pointy side, so x is less than negative 1. It's still going to go to the left, even though the inequality. Sometimes I have students who are like, well, the inequality is pointing that way. It doesn't have to do with that. X is still on the greater than side here, so it's still going to go to the right. So be careful about trying to find the tricks on that and just pay attention to what's happening in your problem. All right, let's look at another one of these. So we have 0.5 less than x less than or equal to 3. So this time I have two numbers. Still need my infinities. I still need the 0.5 and I need the 3. Now, x is greater than the 0.5, so it goes this way. And x is less than or equal to the 3, so it's going to go this way. So this whole part in here is where our answer lies. On the first part, x is greater than, so it just gets a parenthesis, but it's less than or equal to, so it gets the bracket. So 0.53 with a bracket. All right, let's look at another example. Here we're going to do some solving first. So we're going to solve, we're going to graph, and then we're going to do interval notation. So for part A, we have x minus 2 less than 5. So I'm just solving for my x. So I'm going to add the 2 over just like I would if it was an equal. X is less than 5 plus 2 is 7. So that would be my solution. Now I'm going to graph, so that's the solve part. Negative infinity to infinity, I need the 7. X is less than, because it's on the less than side. So that means it's going to go to the left. It does not have the equal part, doesn't include it, so it'll be a parenthesis. So negative infinity to 7 with a parenthesis. All right. Our next problem, we have x plus 5 greater than 9. We'll subtract the 5 from both sides and get x is less than 4. So we've solved it. Let's graph it. Negative infinities and the 4. It is greater than, so it's going to go to the right. Again, is not equal to, so it's just a parenthesis, parenthesis 4, comma, infinity. So notice it's coming straight on down. Sometimes students like to flip it. Don't flip it. It comes just the same as it is up there. All right. Let's go look at another example. This will be part C. So we have 3x plus 4 greater than or equal to 2x minus 6. Now on this one, I'm going to make a choice. I can either move the x's over here or move the x's over here. I'm going to move them over here because I like to have the positive x. We will do a negative x on the next problem, but I like to do it positive because then I don't have to worry whether or not I have to flip the inequality sign. So if I move the 2x over with subtraction, I end up with x plus 4 greater than or equal to negative 6. Now I will subtract the 4 and get x is greater than or equal to negative 10. So negative infinity to infinity, I have my negative 10. So with that negative 10, I am greater than or equal to it. So it's greater than goes to the right. Equal to gets it a bracket. So we end up with bracket negative 10 to infinity. All right, let's look at another problem. And on this one, we're going to deal with that negative rule. When you multiply or divide, we can add and subtract across with negatives, but we cannot multiply or divide across the inequality. So this is the answer, or the question we're starting with. I'm going to divide both sides by a negative 2. I end up with x, and over here I have negative 4. Because I divided by a negative, I have to flip the inequality. So it becomes x is greater than negative 4. All right, let's talk about why that's true. I'm going to take the exact same problem. I'm going to work it right next to it. But this time I'm going to keep the x's positive. So I'm going to add the 2x to the other side. Now I have 0 on this side, less than 8 plus 2x. Now we'll move the 8 over with subtraction. I have negative 8 less than 2x. Divide by 2. Negative 4 less than x, or x is greater than -4. These two answers are the same. They're going the opposite way. I have x greater than -4 and x greater than -4. When we deal with an equal sign, when it's just equals and it's not greater than or less than, we don't have an issue with how the answer comes out because it just stays equal to. But when you have the greater than and less than, if I don't take into account that I divided by that negative, that I flip it, then over here, if I didn't flip it, I would end up with x is less than -4 instead of greater than, which would not be the same answer as this. So that's why when we multiply or divide, we have to flip the inequality, because if I solve it keeping things, the x is positive, this should be the answer I always get because I didn't do any of that multiplication or division across. So that's why you have to take care of that rule. So don't forget it. And it's only the inequality that gets flipped around. Now we have the same answer. We need to graph it. We need negative infinity, infinity, and -4. And it is just greater than -4, so greater than, no equal to, so parenthesis, -4, infinity, parenthesis. All right, let's look at another problem. Here we have 6/7 times x minus 9 greater than or equal to x plus 3. So here we have a fraction. Well, I don't want to multiply the fraction times the x and the 9 and then deal with a bunch of fractions. So I'm going to do what I would normally do. I want to clear that denominator, so I'm going to multiply by 7 on this side to clear it and multiply on this side by 7 because it's the same as when we deal with equations. What we do to one side of the equation, we have to do to the other side. All right, so now I have 6 times x minus 9 greater than or equal to 7 times x plus 3. So 6 times x will get us 6x. 6 times a -9, -54, greater than or equal to 7 times x. 7 times 3 will get us 21. So again, I like to keep my x's positive, so I'm going to move my 6x over. -54 greater than or equal to x plus 21. Move the 21 over. And over here we have -75 greater than or equal to x, or x is less than or equal to -75. So this is a primary example of why I only use the numbers I need and I don't put a bunch on because I don't want to make 75 hash marks on the negative side. I can still put my infinities and I can just put in that -75. X is less than or equal to, so less than goes there. Equal to gives me a bracket. So it's -infinity to -75 with that bracket. And the parenthesis is on the infinity because infinities always get parentheses. So the next problem we're going to look at is a word problem where we're going to set up an inequality to solve the problem. So solve using linear inequalities. So a clerk must use the elevator to move some boxes of paper. The elevator's maximum weight limit is 1,500 pounds. If each box of paper weighs 66 pounds and the clerk weighs 147 pounds, use an inequality to find the number of whole boxes she can move on the elevator at one time. If you need to reread that, you can pause the video, look at the problem some more. So we're going to pull out what we need from this problem. We have a couple of things going on. We have a maximum weight limit of 1,500 pounds. Each box weighs 66 pounds, and the clerk weighs 147. And we want to know how many whole boxes she can move at one time using that elevator. So this would be example 3. First of all, we have to take into account the clerk's weight. And we're going to take the weight of each box and we're going to multiply that by the number of boxes. However many boxes we put on there, they each weigh 66 pounds. So we're going to just multiply that. Now, all of this has to be less than or equal to the elevator maximum weight. You can't go over the maximum or you can have an issue with your elevator working properly. We know that the clerk weight was 147 pounds. Oops, let me do something first here. Let's set up so that you understand what's going on here. So we're going to have a blank plus a blank. The number of boxes is what we're trying to find, so that will be the x. It'll be less than or equal to another blank. So we're trying to fill in these 3 blanks here. The number of boxes, that's our variable of what we're trying to find. So let's write this below it. 147 plus, we know the weight of each box is 66 pounds times the x. We can put that in parentheses up there. And then it's got to be less than or equal to that maximum weight of on the elevator, which is 1,500. So let's subtract our 147 from both sides. And that'll get us 66x is less than or equal to 1,500 minus 147 is 1,353. Now we'll divide by 66. And x is less than or equal to 20.5. Now, we don't want to move a half a box. They said the number of whole boxes. So that means she can move 20 of them. She cannot do 21 because that would put us over. So she can move at most 20 whole boxes at one time. So she could load up 20 whole boxes and run the elevator. Can't go more than that or she'd be over her limit.